Joe for setting up this. So should we start recording and start the presentation? Or should we wait a couple more minutes for more people?
John, are you going to start the recording?
I think we've got quite a lot here already, so we can
He says
go now.
he's recording it, so the recording has been started.
Okay, cool. So, let me share my screen. All right, can you see the screen now?
Yes.
All right, cool. So, all right, I'm gonna get started. So, hi everyone, my name is Xiaoyao. I'm currently a master's student in University of Illinois, and I'm currently co-advised by Professor Andrew Miller. And I'm currently, this summer, I'm interning at Twitter. So I'm currently in the Twitter building in San Francisco. And my intern project has a lot to do with this Presto DB platform. So while I was doing the work, I was also figuring, well, what if we build a Presto DB connector to Ethereum so then we can enable SQL queries basically on Ethereum then? That would be cool. So so let me introduce what is Presto DB. Presto DB is basically, it's not although it's called DB, but it's not actually a storage engine. It is more like a distributed SQL query execution engine. So it does not store data. And it was an open source project, open sourced by Facebook back in, I think, 2011 or 2012. So basically, this is so if you can consider Presto like a black box, and this is a very high level introduction of how it works. So basically you have a client and you can use the client to issue a SQL query, and the client will send a query to the coordinator. Then the coordinator will parse the query, design a execution plan, and then distribute and then the scheduler will distribute the query into multiple tasks, and these tasks will be distributed among different workers. And according to the execution plan, the query execution will be divided into multiple stages, and each stages will do like a particular work. For example, normally the first stage will be pulling the data from the data source, just like these two workers do. And further stages will be doing like filtering on the data and doing aggregations. So there will be workers at each stage to handle the job. And after all the workers, after all the stages finishes, it will return the results finally to the client, basically. So in order to So Presto is special because it is not only it not only allows you to run SQL query on SQL databases, it also enables this ability that as long as you have a connector that connect the Presto engine to some data source, then you can issue query on that, just following some, as long as the connector know how to pull data. So basically you can then use, as long as you have a connector, you can make a SQL query on anything, be it a normal SQL database or a local file or like HDFS or maybe a web API. So it can be anything. So in order to create such a connector, basically you need to implement like these three parts. You definitely need like a data stream API that knows how to pull data from the data source. You also need a metadata API so that the Presto engine will know like what are the columns are available, what types of each columns are, and what is the table name, and such and such. And there, you also need data location API in the connector so that so that the Presto will know like where to get the data from. So these modules are like high-level logical modules, and if in the let's put it in the real case like this, we have the Presto black box on the left, and we have the Ethereum blockchain on the top right. So when a user issues a query to Presto, Presto will first ask the connector metadata. This is like a detail module that you can find in the code. So the connector metadata would then gather like configurations, where is the Ethereum endpoint, and like what is the table, what are the table columns, and such. And then the metadata will then ask the connector split manager, which is also another module, to find out how many splits this query needs. So split is basically the basic unit of how a query is distributed. So you can consider split as the minimum unit of task. So in this case, in the Ethereum case, I consider split as one block. So then the split, so for each split, Presto will create a connector record set cursor for the split. And this cursor, just like its name, it will then parse the block, iterate through the transaction data, and eventually, when it gathers all the data, when it parses all the data, it will pass the data to the next level, to the next stage, to perform like filtering or aggregations upon it. So this is basically how a Presto connector architecture looks like. And well, this slide, I don't think I need to explain more detail on this slide. This slide is for the meetup that happens last Sunday. And I believe we all know SQL. So yeah, so let me show you a couple of use cases of how you can use the Presto connector for interaction. So first of all, let's see. I'm now starting up a Presto client. This is basically what the Presto client looks like, and you can show tables, and it will tell you we have a block table and a transaction table, and we can then describe. Say I want to know what columns are there on the block, and these data. I basically used Web3j. That's a Java Web3 client, which is really similar to the Web3.js. And I used this client to pull data from the blockchain. And these are normally all the metadata in a block. So we can see the types of each column. And the interesting thing is for Presto DB, it supports like container types natively. So we do have like array, and there are also other container types, but it's not suitable in this case. It also supports like set and map and rows. But array here is just like a simple array, and I make it an array of strings. We can also describe what a transaction is. So transaction is these data are also like present in if you call the Web3 client on like getting the transaction. So these are the metadata for a transaction. So with these, we can then issue queries to interact with the blockchain. So for example, in this query, I want to select everything from the block table and where block number is equal to the current block. So this will give me this. Yeah. So this will give me like that particular row where the number is pointing to the current block number. And you'll see like all the data is here. And block timestamp. And I think, yeah, this is like this part is basically the array of transaction hashes. Yeah, it could be long. And also we can also select from transaction table where transaction block number equals to the current block. So that basically means I want to get all the transaction from that block, and this will give me this. Yeah, these are block hashes, transaction, who's issuing the transaction and who's receiving the transaction values. And it also has the input data, but these input data are just simply hexadecimal strings, and it doesn't really make sense right now. So after that, we so this is a one typical use case. If I want to know like the average block time in the last 100 blocks, then I can issue this query. So this query will basically first it will get the block time by subtracting the next block's timestamp by this block's timestamp, and then selecting an average of all this time. And I'm currently only running one node, but like typically you will run. Well, I don't know, but typically Presto, if you use Presto in productions, like in Facebook or whatever, they usually do with more nodes so that they can distribute the workload better. And well, this one fails. This one always fails on me. I don't know why. But yeah, but like one gotcha in this tool is that I'll always have to provide like some predicate on block numbers so that you don't end up scanning the entire blockchains, which will take like really long time, even if you have like multiple nodes. All right, I don't know why this doesn't work last Sunday too, but I'll show you the next one. The next query is to get the largest miners in the last 100 blocks. So this will, for query range like 100 blocks, it typically, like on one node, which is my laptop, it took like a couple seconds to tens of seconds. And this is like one use case I figure will be useful. And then you can also get like average gas and gas price in the last 100 blocks. And that is this query. And there's no cache right now. There's no cache like support built into Presto either. Presto is totally like a in-memory execution engine, and it assumes like some of the data source, like Kafka is one of the supported data source, has constantly changing data. So it does not support cache, but like adding a cache. So that's why like every time when I issue a query, although it's almost over the same block range, it's still like getting the same blocks over and over again. Adding a cache will be like on my roadmap to improve the efficiency and performance. And this will give, and this query like works. This gives the average gas used in the last 100 blocks and the average gas price in Wei. And then how many ethers are being transferred at the moment of speaking. I have another query that do that. It's like this. And you can notice that these queries all have are able to call some utility functions that is also presented in Web3.js. It's like from way, you can like you can like convert way numbers to ethers, and also you can call like ether block numbers. This function will return you the current block number basically. This query should return the number of ether being transferred over the network in the last 100 block, and this is really a lot of them.
I have a question. Is the actual data still stored in a level DB, like just in the regular file system that, I don't know, Geth uses or Parity uses?
So in this I started this Presto CLI with the backend pointing to the Infura network. I don't have a local node running or anywhere, but if you have like a local node syncing up to date with the blockchain, then you can definitely like point the backend to your local node. And you know, when you are querying a local node, under the hood is actually talking to a level DB, right?
Interesting. So it's limited to RPC. It's doing lots and lots of RPC calls.
Right.
Okay.
Yes. The client I was using, the library I was using is the Web3J library. It supports through JSON RPC. It supports IPC, the Unix socket, and the Infura as backend. So right now I'm using Infura, but yeah, you're right. Like every query will under the hood it is actually firing a lot of JSON RPC calls to the local node. And this also brings up another problem is when you want to deploy this tool to say like 25 nodes or 50 nodes. Either you have to configure all of the 50 Presto workers to talk to one Ethereum node, or you have to basically run this node on every one of them. So so they have like more like data locality to be quicker. But yeah, that's basically also like that could also be a possible performance bottleneck. Yep, and you may wonder like what is special about this Presto engine. I can totally do the same thing by like dumping the data into a MySQL table and then run the same SQL query, right? So I figure this tool is useful in the sense that these 6 points. So first of all, it's a real time. As long as your node is up to date, you can start querying the node, and you'll always get the latest data. It's also distributed. You can deploy the multiple nodes, although you do have the bottleneck problem where you have the single Ethereum node possibly being a bottleneck, but it's distributed. And the third thing is zero. It has zero overhead, because if you dump data to MySQL, you definitely need like more storage to hold all those data. Then you basically have a node, an Ethereum node that already has all those data, and then you also have a MySQL table that potentially also has that much data. But for Presto, query are executed in memory, and there's no storage. It doesn't require storage; it just pull data at real time into the memory and then do execution. The fourth thing is support Infura, which is a great product. I just get to know it recently. And it has built-in Web3 utility functions like from way, to way, like ETH block number, get transaction count, such and such. I have an issue on my GitHub that tracks like how many utility functions I have implemented and how many else I haven't done yet. And the last thing, and it possibly is the most important one is Presto allows you to query across different data sources. Like I said earlier, like as long as you have a connector, oopsie. Still, well, okay. I guess you can still hear me. My my laptop. Anyway, so you can issue cross-source query as long as you have a connector for that data source. So like one use case I could think of is if you have a MySQL table, for example, that contains all the Ether price history, and then you can basically make a query to join the Ethereum table with the price table together, and you can potentially find like when, or like what are the behavior, what is the pattern before a Ether price surge. And Presto itself officially, they support like a bunch of different backends. They support on top of my head is like they support Cassandra, MySQL, PostgreSQL, Redis, Hive, and Kafka. Yeah. So on my roadmap, there are currently three things. The first of all is to optimize the query performance, because this might include adding the cache to so that it does not have to fetch the same block over and over again. The second and third thing are kind of related. I want to explore if I can use Presto to track like smart contract internal transactions, just like how Etherscan works. And if I'm able to do that, I should then be able to like track ERC20 token movements in. Well, if that can be done, that would be really cool, and it could be useful for anyone who want to build like trading bots on tokens or whatever. And and finally, like this one is actually like a hackathon style project. I just came up with this idea one day at work, and then I spent like a day, 2 days, 2 nights basically to finish this. So there are still problems, unstable query results, and I like welcome all the comments and suggestions, feedbacks, or contributions. I want to know like how I can make it more useful to people, basically. And I think that's it.
Yeah, thank you. Yeah, is there so we have like members like from Inspira here, protocol team, and a variety of other people who are interested in what you've been doing. So if anyone has any questions or suggestions for you, please go ahead.
So the two tables that you support are the transactions and blocks, or is there more? Or I'm sure it's in the README on your GitHub here, but
yeah, the two tables that are currently supported are block and transaction. They are from the same source anyway, right? When you get the transaction, you need to get a block first, and then fetch all the transaction from there. Yeah, there are other like I'm constantly popping up ideas, but I'm not sure if it is like doable. I was also thinking of having like a third table that tracks all the events, like the log events in the node. Not sure.
I think that should be possible. Like I would think the next easiest thing would be receipts, because receipts.
Transaction receipts, right?
Yeah, I think they're like stored in the block too, or
right,
something like that. And then inside the receipts, there's like an array of all the logs for that receipt.
Yeah, definitely. I also have I have a ticket actually on the receipts. It should not be hard to add it. Yeah, as long as Web3j has this function to get receipts, it should be easy to put it into the Presto and make it a table.
Hey, this is John. Thank you. This is super interesting. You mentioned at the beginning that you essentially need to have a database schema set up for the queries. So where do you have like an interface for that, or where does that exist? And is that setting that up just very similar to doing so for a database?
So currently the schema for the two table, I have the block table and the transaction table. The schema is hard coded in the code. But I do notice that I hard coded because well, first of all, it's easy, and then the schema doesn't really change a lot for those two tables. But I do notice, like I was working on Presto Kafka previously connector, and they basically ask you to provide like a JSON file that describes the Kafka queue. What is the schema of each message in the queue, and then they parse it on the fly and basically construct a table on the fly. And I think that's also a way to do that. Like I can also support that way, but I don't know what are the use cases, like why people would want to modify the schemas, but it's definitely doable. Yeah.
Cool, thanks.
Hey, Yao, have you benchmarked any of this? Like, have you tried to scan every row on a local node and just seen how fast it is or anything like that?
Unfortunately, I have not benchmarked it because I don't really have a fully synced node on my local machine. When I was developing it, I was using I was connecting it to the light mode Robston network. I do have that fully synced, but it's light mode. So when I was demoing it, I connected in Fura. So I haven't done benchmark.
Cool. All right. Yeah. I'm glad to help you with that if you want. So.
Yeah, that would be great. I think bench. Another problem is also I don't know. I haven't actually deployed it to more than one nodes yet. All the work, all the demos are just running locally. Yeah, I don't know if running it on multiple nodes where all those nodes are connecting to one Ethereum node. I don't know if that will overwhelm the Ethereum node. Like, what is the limit, or But
hey, this is Johannes speaking from Alethio. I did miss the beginning of the call. So what was again the use case for having it on multiple nodes?
Having it on, so basically if you have multiple nodes, you can, so basically these splits are the base unit for the execution of the query. The split manager here will split the query into multiple smaller unit, and each split is like one block. And if you have multiple nodes, multiple Presto nodes, basically, each node will have each node will receive will be assigned with some splits, and the more nodes you have, the more parallel your execution will be.
Yeah, sure. That's what I thought, but yeah, okay, makes sense. Right. Thanks. So, but there's probably some SQL queries that you should not run, like account or something like this.
Right. So yes, and currently this connector only supports read-only mode. So if you issue insert or yeah, basically if you insert or update, those normal SQL operation, this will not work.
That would be fun if you could insert a row into the transactions table.
Right. I was also thinking about, because the semantic of insert is basically like making a transaction. So like potentially, people, if that is supported, people can use this as a client, in addition to like Geth or Parity. But like one gotcha is if you have like more than one nodes, the insertion will also be distributed to different nodes, and that could be that could be a problem. You definitely don't have guarantee on which, you definitely don't have the guarantee on the order of insertion. I'm not sure, but still thinking about this.
Yeah. Okay.
Hey, yeah, this is Maurice from Infura. It's great to see this project on the Infura integration. I was just curious about the part where you get the Web3 methods. So you had to do some sort of connector there too, and it's just talking to the backend like all the workers?
Yes. The utility functions, except for like really simple utility like from way and to way, but other utility functions like get transaction count and get block number, it does like issue a call through RPC to the node to ask for a number.
Okay, cool.
Yeah, that part in the code is also like kind of hacky, because in Presto, these functions, these utility functions, they are similar to like normal max, average, and those kind of utility function, and these functions are static. So yeah, it's a kind of hacky to have a global static Web3J library object there in the static field.
Uh-huh. Well, we'd be happy to talk to you about this. We've been trying to find you since the Hacker News article. But
Okay.
Here you are.
Yeah. I was curious though. If Infura has any like rate limit.
Not really. Not really. We try to scale up as much as possible. We did experiment a little bit with rate limits, but it created problems for people, so we just backed off.
Okay.
Yeah. In the meantime, yeah. If you have any the other questions for Infura as well, while people are thinking of questions for you or something, go ahead and
Sure.
ask.
So like the main I have some concerns on the Infura. Basically, the first thing I just asked like if there's rate limit on Infura. Also, I would like to know like if Infura has any plan to support like debugging API in Geth or the tracing API in Parity.
We do support those, not on the endpoints you're using, just because they're used by a bunch of other people, but we can provide those too. We have a different set of nodes that you can use.
Yeah, that would be great, because I figure I don't know how long it would take for me to get a fully synced node on my machine. But if Infura has the support of those API, I can potentially unblock like these two features.
Sweet, yeah, we'll hook you up after this call.
But if you do a parity node and sync a parity node, it should take only like an hour to sync, usually.
Really?
Yeah.
But he wants like a full node with all like previous state histories. If you do like the fast sync or the warp sync, it'll do like state tree pruning and stuff.
Okay.
For full archive and trace on Parity, though, it's much longer.
Yeah, and it really depends on your connection also and your processing speed, because it will eat up everything. But we have really had great sync times on servers. So on private machines, it should be a bit longer, but not too much. So it's doable. Just try it.
Okay. Because I have I read the documents on Parity, and it says if you want to use the tracing API, you have to have a full sync.
That's true. Yeah, you have to do that. But it's not as slow as I mean, have you tried it? It really works well nowadays, is my experience.
Sure. I haven't tried it yet. I was also living in Airbnb this summer, and the Wi-Fi really sucks.
Okay. Yeah.
Yeah. We'll try it when I'm back home.
Yeah. By the way, to support ERC20 tokens, you probably wouldn't even have to look at the traces. You could just look at the logs, which are in the receipts.
Oh,
right.
Okay. Yeah. But those logs are also like hex strings, right?
Yeah. Well, yeah.
Like any way I can decode the hex string.
Well, you'd have to know what well, for ERC20, you know the structure of the contract, you know the ABI, so you can identify those that are relevant to ERC20 and identify ERC20 events. But in the general case, of course, you don't really know what to do with the logs, because you have to know something about the contract.
Oh, I see.
In the case of ERC20, that's not the problem, because it's fairly standardized.
I see. So because it's fairly standardized, so that makes like those log like parsable,
understandable.
Okay.
You know what topic means what, and
I
what
see.
topic is the identifier for a transfer, for example.
Okay. I will try that. Yes.
Cool. I think this project really makes Ethereum data much more accessible for those that may know SQL, which there is a huge community out there, and those that don't really want to handle RPC calls and understand the JSON that comes back. So yeah, I think it's really a great improvement in accessibility for short or for small scale analytics or yeah, alerts, events, these kinds of things where you want to create something quick. And yeah, I think it's useful for that.
I have one more quick question. Do you know if Presto can give you access to like the number of bytes scanned when you run queries? Like, does it give you like data like that?
Oh, yeah, I think so. Yeah, it definitely does. So like for example, this query, the last query I run is to get the number of ethers in the last 100 blocks. This is basically the number of bytes scanned. Well, it's actually not byte scan. It's the byte that you processed.
Right.
That's similar to byte scan, I suppose, because there doesn't seem to be compression or whatever.
Okay, cool.
Yeah.
Very interesting.
These row numbers are like it does not mean how many rows though. Well, yeah, there probably is how many nodes? 8,000 transactions in the last 100 blocks. But these row numbers are typically like the number of rows that you scan plus some intermediate rows that is used to do aggregation and filtering. So, but this also like tell you how many rows you scan basically. Sorry, who's the other? There's another question I heard.
I just posted a project in the chat that you might be interested in looking at. a different approach, but it dumps the chain data to, I think, Postgres, and allows querying of it in SQL. It's by a guy who a number of consensus folks have talked to and worked with, and maybe part of our company now. Anyway, you might be interested in checking it out, and I just posted it in Slack or the chat.
Cool. It is this one, right? The quick blocks?
Yeah, yeah.
Sure. Yeah, I will take a look at that.
Who's the person behind Quick Blocks?
TJ Rush.
Okay, he is part of the mesh now.
Great.
Yeah, so as further introduction to Yao, yeah, he was first brought to our attention months ago by Andrew Miller, and he's now yeah, considering a PhD, but I think maybe he should consider like some kind of at least internship with consensus. So it's great that yeah, everyone's been engaging with him. But if you have interesting points to mention about what you're doing with in consensus, I think it's fair to be able to share it with him.
I'll even go outside the box. Now, Joseph said you're considering a PhD. If you just want to call up and talk to people more generally, as you think about that decision, if that's not a decision you've made firmly now, feel free to call me and I will help connect you, coordinate, or you know, just be a sounding board if you'd like to do that. I'd be happy to talk further beyond the technical topics, but topics of your career, where you want to go, what are your goals and objectives, and how that might fit with different options for you.
Sure. Yeah, I have been thinking about this for months now. Not sure if I should do PhD, you know, given still have some financial burden. Like the sooner as I work, the better. But I had this idea because I thought since I was already doing masters, so it only take like 3-4 more years to get a PhD degree. But I'm not like really into like being a professor or whatever in the future. I would still be like to work as an engineer. And many people told me, you know, if you're not interested, if you're not passionate about academia, you shouldn't do PhD. That'd be painful.
That's because I could sense you had some question about that. That's why I offered. So let's not do that on the call anymore. But
sure, yeah.
Joseph Chow can get you in touch with me. We have several PhDs, and we have people who are working on PhDs and decided not to keep working because there was too much going on. So whatever you want to do, we'll be happy to engage.
Sure.
And I personally will be happy to.
Okay. Yeah. Sure. I'll let Joseph know to link us together.
Yeah, just go on to give yeah, anyone else who has questions so far. So I have two things. Then the first one, I guess, is a question to Johannes. He's asked you a couple of questions, Yao, and I'm just wondering if yeah, feel free to say or not say whatever you think is appropriate, Johannes. But maybe I pointed him to Aleph.io, but then I saw it was an empty page. But anything there that might be interesting for Yao to know or collaborate on?
Yeah, sorry guys, or sorry Yao about the empty page. We're just right now finishing our identity set and are creating the first page. We've been working in the background though for a couple of months now, and yeah, we're doing pretty much the exact opposite, because while you have a very lightweight approach by just using a parity node to fulfill SQL queries, we're doing the exact opposite. We're getting all the information from the blockchain, we're parsing it into a different format, we're reorganizing the data so that it fits to our schema, and then we're putting it in two different types of databases to be able to run SQL queries on the data. So it's exactly the opposite. Like you said, it's the data or the storage intensive way is what we're doing, and what you're doing is the lightweight approach. And I think they both live in their own right, and they both have their use cases. That's my main takeaway.
And my second, I guess, suggestion, but I guess, it's more limited. I think definitely some people are interested, and this is why Iliathio is going that approach, is to be able to query more data. I think Zach was trying to figure out if we might be able to query things like, accounts and balances and their code, things like that. I think Alan Liu from Gnosis, he also asked if all the data is right now just being pulled from RPC.
Mm-hmm. Yeah. I think supporting more. Definitely it's valuable to be able to support more data. I'm also still like exploring how can you get more.
One of the most difficult things that you will have to solve if you want to support more types of queries that are doable in a short time is to solve how you can move from block-centric queries, which are kind of easy to solve because they touch only a few blocks, to account-centric queries. Like if you want to know in what blocks an account has appeared and doing something or being some, then you have to basically check all blocks, and that can never be fast. And if you use the block part of the Parity API, so because you basically always have to scan all blocks to find things like that out, right? Or do you have an approach that I missed here?
Yeah, you're right. If you want to do that basically will need to scan all the blocks, or like you lose the accuracy by specifying a range. I just want like this block range. I just want to know this user's behavior in this range.
That will work.
Right. Yeah. I see. Yeah, I think the more heavyweight solution that you're working on will, if you restructure the blockchain structure in a different way, index it in a properly, it should be like much quicker than just scanning all the blocks, right?
Well, yeah, it really depends on what you want to do. So for some queries, you demonstrated some, this is really useful. But there are other queries that are really hard to fulfill with this approach. And there are probably optimizations, but Parity organizes its internal database based on blocks. So any query that goes cross-block, that's how I would describe it, is hard to fulfill using this. It's just probably a fact. Maybe Parity provides some RPC methods that help you with that a bit, but still they would have to query their own internal level DB by keys. And if they don't keep another index, then they also can't fulfill these queries faster than you can probably. I'm not 100% sure how they organize internally their level DB, but it's level DB, so it's key-based, and it implements a Merkle trie. So in the end, you will always have to traverse it. And certain things are fast on that approach and other things are slow. And this, of course, also propagates to their RPC API.
Okay, if there's no other questions, we'll thank you, Yao, and everyone who got the email invite should see his email there. Otherwise, just ping me or Kirk or whoever, and we can connect you with Yao.
Thank you, Yao.
Thank you. Thank you for having me.
Thank you, Yao.
Thanks for the feedback.
Thank you, Yao.
Thanks a lot, Yao.
Thank you.
Thanks and bye.
Thanks. Take it easy.
Okay. I guess when I leave the meeting, it might end the recording. So yeah, thank you.
Thank you.
Thanks, yeah.
All right.
Okay. Bye.
Bye.